In this recording, we will discuss a few more applications of flat mirrors. For example, this is a typical question that's usually asked: what size mirror does a person need to see herself or himself? Okay, now we have a simulation to try to illustrate that I'm going to use. Okay, here is the simulation. Here is our civilized person, and this is the light, for example, being reflected off the toes of this person, but we can change this to another part of the body if we want to. It is supposed to allow me to change it here, and we'll see where the image is for that part. Now, as you notice, what we can see here are only the parts that this person sees. That's, if I put something here, for example, the light reflected off the mirror that looks like coming from that location is not going to go into this eye, so we don't see it. So the nice thing here, we can actually use this arrow to somewhat measure the size of this guy. Okay. So we have something approximately his size, so we can compare to it. And we are going to move this so we can see the head. Actually, we are going to move it back till we barely see the toe. There we go. And move it till just the head. So now you notice that light coming from the toe, part of it is going to be able to reach the eye. Light from the hair. Some of it barely there, get into the area of the eye. So we should be able to see the full length with that size mirror. Now, what's this mirror? See, it's about half the length of the person. Okay. Now with geometry, how would you determine that? So what do you need? You need one light beam coming from here. That's assuming that's the bottom of the mirror. And coming here. Remember, this angle is the same as this angle. Now, as you notice, look here at the height of this, where it is. It is at the height of the eye. Essentially the height of the person, approximately. We are assuming that it is at the height of the person. Okay, now to be able to calculate this, since this angle is the same as this angle, this is the same as this. And what's this? That's the size of the mirror. Remember the mirror, we are starting here. the bottom. Okay, so the mirror needs to be just the height of the mirror is half of the height of the person, approximately. Okay. Another interesting thing that's worth looking at, it does not involve calculations, but it's interesting. Okay, we have here a tiger walking towards a mirror and walking away from it. With a flat mirror, the image of the tiger is the same, no matter how close to the mirror he gets or how far away from the mirror he gets. Okay, and one last example is what if we have multiple mirrors, like these two mirrors that are perpendicular to each other? How many images are we going to be able to observe? Okay, now the simple thing, you would think here is the money, so I should have, like we talked about, the straight line. Okay, and then other than the straight line, we make something at an angle. Okay, at an angle such that it's going to reach the eye. So let's see here, something like this. Okay, so this is part of the money. Okay, we can do the same thing here. And then it does not have to be there, that's I need to erase that. Okay, so we need something at an angle so that it will hit the eye. So for example, this will do it. This is another image. Okay, now, is there any other image? Okay, to explain it, I'm again going to resort to a simulation, the simulation that's in it. Notice what we have. So this is again our object. It's not money in this case, it's this. Light reflected off of it. That's all the light. Now it's going to form this image here, same as the one I drew. And then from here we have this image here. But then also what do we have? We have light that's reflected, for example, from here, that's coming from here, that's coming here. And what is it doing? It's coming off this way. We have light reflected like this, and coming off this way. What does that light look like? It looks like it's coming from here. This light beam, it looks like it's coming from here. So the multiple reflections of the light are going to produce another image for me here. Let me run the simulation to show you. Okay, so let's close this. So this is the mirrors. We can set them up at an angle of 90 degrees. Okay, actually, by the way, when we have different angles, we can have even more images. And this is like at 102 degrees, about 100 degrees. So that's the primary images formed. And then the multiple reflections are resulting in these extra images that we have here, that we see here. Now, if my angle is 90 degrees, these two extra images are going to result in one image here. Again, remember, like, where is this beam coming from? It is light that came from here, reflected here, and then reflected back there. Multiple reflections. Now, in summary, for flat mirrors, we have an image that's identical to the object. It is upright, same size, same distance from the mirror, but behind it, the image distance is the same as the object distance. It faces the opposite direction. It's left-right inverted relative to us. And it's actually, if you think about it, it's left-right inverted because it does not really change. But that's mainly based on us, the way we look at things. It is also up and right inverted, if you'd like to think about it that way. But then our eyes are not up and right, are not positioned vertically, so we don't notice that. And the image, we say it is a virtual image because light don't actually intersect there. We don't form an image there. Okay, in the next recording, we are going to talk about curved mirrors. Here is an example of possible curved mirrors. This image is from the same website that we used for specular and diffuse reflection. We used it also to show the colors, reflecting objects of different colors. Now, we have two spoons. In one of them, you are looking at the concave end of the spoon, and the other side you are looking at the convex end of the spoon. And we are seeing two images. One of them is showing this lady upright, and in this one it's showing the lady upside down. Which side is it? I wonder if you ever tried it with a spoon. I hope you did. So that's what we are going to discuss in the next recording.